Welcome everyone to the last day of the Tropical Topics Week put on by your local Florida National Weather Service offices, the National Hurricane Center, and the Florida Division of Emergency Management. My name is Daniel Noah, and I'm the Warning Coordination Meteorologist at the National Weather Service in Tampa Bay, located in Ruskin, Florida. And working behind the scenes with me today is Jessica Few. She is a lead forecaster with a focus in tropical weather at the National Weather Service in Tallahassee. Due to the large number of participants, please type your questions in the question box and they will be answered at the end of the training session. And if we don't get to them, we will send you an email with the answer. This presentation will be recorded and will be made available. However, we will end the recording before the question and answer portion. Recordings and PDFs of the training will be available. In fact, Monday through Wednesday are already available on the website that you use to register. The link to that website will also be in the email you will receive in about an hour after the training ends. This email also has a link to your training certificate, so please remember that the certificate takes a minute or two to complete once you click the link. With that, Jessica is going to turn over the presentation to Scott and Rob. Scott Spratt is the Warning Coordination Meteorologist at the National Weather Service in Melbourne, and Rob Moyeda is the Warning Coordination Meteorologist at the Weather Service in Miami. With that, go ahead, Scott.
Okay, very good. Thank you, Dan, and good afternoon. Again, I'm Scott Spratt with the National Weather Service in Melbourne. And today we'll be talking about tropical cyclone tornadoes. So I'm going to start off by reviewing several previous events that have occurred across the state of Florida and use those as a resource to show some of the impacts and hazards that affect our area from tropical cyclone tornadoes. We're then going to look at a long-term climatology to determine the area around the tropical cyclone circulation where tornadoes are most likely to occur. And then we'll look at a number of favorable patterns, the tracks of the hurricanes and tropical storms themselves that make tornadoes more conducive to develop across the Florida Peninsula and Panhandle. We'll then look at a past case that if it were or when it does occur again in the future, will likely present a worst case scenario for the state when it comes to tornadoes. Then I'm going to turn it over to my colleague Rob Moyeda in Miami. He's going to discuss the communication of the threats and the impacts associated with TC tornadoes. And then I'll end up the presentation by talking about a couple future changes to tropical cyclone tornado warning, the tropical cyclone tornado warning process that may be coming about in the next several years. So with that, I'm going to start off with a question, and this is not a poll question, so it's just something for you all to think about for the next few seconds here. But what tropical cyclone hazard poses the greatest threat? So just take a few seconds, think about this. You've probably seen this question before or have heard it talked about previously. And I suspect most people would pick either B or C, one of the water-related hazards. But in reality, for any particular tropical cyclone event, a particular event, it could be any one of these four for that event. So the true answer, it's a little bit of a trick question. It really depends. It depends on the situation. It depends on the particular storm and hurricane track, and more important, where you are, where you're located, where your jurisdiction is relative to where that track is or where the center of circulation is from that tropical storm and hurricane. So many times when you look at a composite of all the different hazards that can occur and you're asked which is the greatest hazard, it certainly is the water-related hazards. It is the storm surge flooding and it is the heavy rainfall. So if you look at a decade or multiple decades of data and you're looking at a large area like across the Gulf Coast or along the entire US coastal areas that are impacted by tropical cyclones, it's going to be one, it's going to be B or C. But again, for a particular event, it could be any of these four hazards, and many times it is the tornado hazard. And we'll talk more about that in a few moments here. So we're going to start off by looking at one particular event. This event occurred over 25 years ago. We're going to talk about Tropical Storm Gordon. Gordon peaked out at a medium intensity tropical storm. You can see the long meandering path that occurred well over a week's time after it developed down near the Central American coast. It meandered about slowly, worked its way up, meandered around the island of Cuba, made landfall on the southwest Florida coast, crossed the south central peninsula, and then did a loop out over the Atlantic and came back towards central Florida in a much weakened state several days later. But I want to call your attention to the red dot here just to the northwest of Key West, because at that time, a tornado developed along the east central Florida coast. It actually started as a waterspout over the intercoastal waterways of southern Brevard County and then moved onshore the adjacent mainland. 6 tornadoes developed with this tropical storm across south and central Florida, but this one by far was the most dominant one. It turned out to be a F2 intensity tornado, winds well over 100 miles per hour. It only was on the ground for a little over 2 minutes with a ground path of about 2.5 miles and a width of only 25 to 50 yards of damage, but it turned out to be very significant. It affected the Barefoot Bay manufactured home community in southern Brevard County. That's the largest manufactured home community in the state of Florida then and is still today. And obviously, due to the densely populated manufactured homes in that area, caused a lot of tremendous damage. So over 500 homes were damaged, over 60 were destroyed. There were 40 injuries. A couple of those were significant injuries, serious injuries, and 1 fatality resulted as well. And even though the system affected the state of Florida, much of the state for a long period of time, with rainfall, with some winds, and with some minor storm surge flooding along the southwest Florida coast, this storm will be remembered by most because of the tornado production that it had. And in fact, within Brevard County, and specifically around the Barefoot Bay community, even 25 years later, this is the storm that many, many people remember. Even with all the hurricanes that have affected the area over the last couple of decades, this one stands out in their mind because it was so dominating, so impacting to the residents there of that manufactured home community. So for a particular storm, tornadoes can be the most serious hazard in a particular jurisdiction. So in the National Weather Service, we consider 4 challenges to be primary when it comes to tropical cyclone tornado forecasting and messaging. First one is predicting tornadoes outside the area where people are prepared for the hurricane force winds. So when the hurricane track is forecast, and that forecast is coming into a better agreement, a better solution, and you're looking at where that hurricane is likely to move with the hurricane force winds over coming days, people in that area obviously have a high degree of sensitivity to that. They're aware of that, they're preparing for that. But what about outside of that? What about the peripheral effects beyond that area where some tornadoes may develop? Well, people in that area may not have the high level of attention that people have more focused inside the actual track where the main impacts are going to occur. And also, you could have a hurricane moving up towards the particular area, and maybe a day or 2 prior to when the core impacts of the hurricane are likely to reach that area, the peripheral leading rain bands, well to the north and east of that circulation center, can produce tornadoes across that area. So how do you get people's attention? How do you focus them to the potential threat that may occur a day or 2 before the more significant primary impacts come with the punch of wind and the flooding rains closer to the center of circulation? Also, unlike the tropical storm Gordon case, predicting tornadoes from weaker systems. How do we get people's attention when people hear many times of a tropical storm approaching? They lower their guard a little bit compared to if a hurricane was coming, or certainly if a major hurricane was coming, because they think it's only a tropical storm or maybe even only a tropical depression. But there's times when those systems can produce the most significant impact, and those could be tornadoes. Also, there's several cases in the past where there's been a large amount of overwarning. A large amount of tornado warnings have gone out. There are some tornadoes, but nothing close to the amount of warnings that have gone out. And we'll talk about a particular case in which this happened previously. So we're aware of that situation. We're trying to compensate for that, and we'll end the presentation by talking about a couple of future changes that could occur in coming years to help out with that. And then messaging. How do we communicate the primary challenges, number 1, 2, 3, shown in this particular diagram? And we'll discuss that as we go on in time here. So one of the ways that we address the primary challenges is to look at the series of work that's done within the forecast office during any tropical cyclone event. We go through a series of assessments. We start with a threat assessment. We go into an impact recognition, and then we end up messaging or communicating that information based on the threat and the impacts expected. So this triangle that you're seeing here, that I'm going to describe in just a moment, it's the National Weather Service equivalent to what I would say the incident management when you have the planning P. It's the way that we go about planning and responding to a threat from the impacts. So we start off with our assessment of the threats. We look at the forecast from the National Hurricane Center, the track, the structure, the intensity expected over the subsequent 5 days. We downscale that information to our local area responsibility. So in our case, East Central Florida or South Florida or West Central Florida. And then once we do that, we take into account computer models and look at the different complexities of how conditions may change, impacts may change county to county across the area responsibility. And then we look at the large scale for pattern recognition. We look at past events and climatologies to determine what may happen this particular time. So once we do that, we interpret those impacts. We determine what the impacts are most likely to be, which ones are most likely to be serious during this particular hurricane, what areas they're likely to be most dominant within. And then we take that and we message it. We communicate that to our partners, in this case, to the general public. So we determine the right strategy for messaging the most serious impacts to the community. While that is going on, we have some additional forecasters doing the same thing. They're going through those same three levels, but they're doing it for unique and specific partners. They're doing it for our public safety, emergency management, and first responders. So they're assessing what the threats are as well. They're using unique thresholds. For example, in emergency management at the county level, it may be when is the time period of onset of 40-mile-per-hour winds, sustained winds, and they're using that as their unique threshold, and they're determining how to interpret those impacts and when that time period is most likely to occur for particular areas. Then they're tailoring that information and tailoring the delivery to communicate the message differently than we would to the general public, because now we're speaking directly to our emergency management partners, or perhaps to the media partners that we're working with. And then we provide a level of dedicated support, constant support, to help them out with decision-making processes within emergency management, public safety, and within the news media to keep a consistent message going throughout the rest of the storm. So in the forecast office, when we're diagnosing the local tornado hazard, we're obviously looking at certain weather factors that enhance the potential for tornadoes with a landfalling or paralleling system towards the state. The most important one is going to be strong low-level wind shear. This component is many times maximized in the right front quadrant relative to the direction of motion of the tropical storm or hurricane. We're also concerned about pockets of dry air. This dry air can occur in the middle to the upper part of the atmosphere, and it can enhance the instability around the peripheral far north and east rain bands preceding the core impacts from the hurricane. And many times these, within the areas of the dry air, isolated heavy showers and thunderstorms develop. And since these showers and thunderstorms are more isolated in nature, they're not competing for that ingest of warm, humid air into the circulation of the developing shower or thunderstorm like it would be if it was scattered or more numerous or widespread showers and thunderstorms. So that dry air allows the individual cells to space out more, become more isolated, and become more conducive to a rate of rotation later on in time. We also look for the interaction with other weather features, especially early and late in the hurricane season. We could be looking at a front lying across a portion of the state well in advance of the hurricane that's approaching our area, and that can enhance locally across that area the likelihood of tornado formation. We look for very subtle wind shift boundaries or mid and upper level troughs and other disturbances in the atmosphere that can increase the ability for tornado production in a particular area. Also, the threat can begin for tornadoes 1 to 2 days in advance of the landfall or the closest point of approach, and those tornadic conditions can linger locally for 1 to 2 days after landfall in some areas as well. So this could be a long duration event. Outside of tropical weather systems, when a tornado watch is issued for a particular area, it's typically issued for 6 to 8 hours of time. But in hurricane situations, they're usually issued for about a 12-hour block in time. and sometimes they're extended for an additional 12-hour period, especially if the tropical storm or hurricane is paralleling the state. So these favorable conditions for tornadoes can last a considerable amount of time. And this gets to the point of tornado fatigue, when people are expecting or anticipating the possibility of tornado formation for 12 or 24 hours. They can get tired of waiting for it, and they start to lower their awareness. Well, that first tornado in that particular area may not occur until 24 hours after the initial watch goes out. So we have to be able to message and keep that assessment going and let people know that it's still a serious threat for tornadoes, even if it's a long-term time period that's going to occur over. The majority of tornadoes occur in the right front quadrant relative to motion. So if a system is moving in a northerly direction, that right front quadrant is generally from about 11 o'clock to 4 o'clock on the old-fashioned clock. Most storms approaching Florida are approaching in a northerly direction, and maybe a track towards the northwest or towards the northeast, but generally in a northerly component. So somewhere in the 11 o'clock to 4 o'clock time frame or quadrant of the circulation is where we would expect the majority of tornadoes to occur. So the next slide here shows a long-term climatology looking at over 50 years of data showing where the tornadoes occur relative to the center of the tropical cyclone. And it's put in a coordinate system here where we're looking at it relative to the direction of motion of the system. So the vast majority of the tornadoes, 90% of the tornadoes in this almost 60-year study, fell within that 340 degrees to 120 degrees of the compass direction, the northeastern quadrant of the tropical storm or hurricane. And you can see the tornadoes occur anywhere from just outside of the center of circulation from the eye wall to the midpoint range to the far peripheral outer rain bands that can be several hundred miles away from the center of circulation. And again, that means that the threat begins far before the core of the hurricane reaches the area. It can be the first threat to arrive across a particular area. So that's with a northward or generally a north component of motion. What if the component of motion was due west? This would be a system more likely to occur moving across maybe the Northwest Caribbean Sea or towards the Yucatan Peninsula or through the Gulf of Mexico at a fairly low latitude. So if we have a westward moving tropical weather system, that right front quadrant, it tilts around, and we're looking at the area from 8 o'clock to 1 o'clock is the area where most of the tornadoes are going to occur. So in a situation like this, with a system moving at a low latitude south of Florida, it may put the Florida Keys or the southern peninsula of Florida still within that favored quadrant for tornadoes to occur with a track south of the state. If we look at the overall circulation of a hurricane, and we're going to take Hurricane Charlie as an example here, there's two well-defined areas where most of the wind-related casualties occur. The most obvious one is near the center of circulation, so within that inner eye wall. So within that inner eye wall, you're seeing here on this particular radar depiction, that area bright red, those are the strongest winds, non-tornadic winds, associated with the core of the hurricane itself. So as that area of very strong winds is approaching a particular area, if the winds are 115 miles per hour, basically category 3 or greater, expected to reach a land area, an extreme wind warning is issued for that particular area. The warning is not issued very far in advance. It's only issued about an hour before those winds are likely to increase. And the onset of those really strong winds occurs suddenly. So the extreme wind warning is really a last opportunity to get the public's attention before those most dominant conditions of the hurricane reach that particular area. So hopefully in a situation like this, everyone's sheltering in place already. They've got their hurricane shutters up, they're sheltering within their homes. But when the extreme wind warning comes out as a last resort type of warning, the last warning they're going to get before those impacts occur, we want people outside of the storm surge zone to take that warning, basically the equivalent of a tornado warning. We want them to shelter inside of their shelter, move away from the exterior walls or windows of the home, get more into the center of the home, get into the lowest floor of the home, and shelter just like you would if a tornado was approaching. So you're sheltering inside your shelter, and you may remain in place for an hour or so as those most intense winds pass by. The second area of interest is that right front quadrant now associated with the tornado threat from the hurricane. So with Charlie moving to the north-northeast in this particular case, the area encompassed by those two white lines is the northeastern quadrant in this particular example. And if we look well up to the northeast of the center of circulation, there is a primary outer rain band where you see the bright red colors in the radar pixels here. So within that particular rain band is where we're going to see individual rotation set up within showers and thunderstorms that could bring the potential for tornadoes. So as the tornado threat is increasing, we issue tornado warnings for individual showers and thunderstorms that acquire rotation and are likely to produce a damaging tornado at ground level. And we issue those particular tornado warnings. So two primary areas, near the storm center, near the hurricane center with extreme wind warning, and then in that northeastern quadrant, many times well out in advance of the approach of the core, maybe a day or two in advance. In this case, it was about 12 hours in advance of the approach of the most damaging winds near the center of circulation. But again, we want to get people's attention focused because that's the first threat they're going to experience is the tornado threat. This is an older study that was done some time ago, but it's still very relevant data. It's looking in particular at the state of Florida. And it's looking at where the tracks of the tropical storms and hurricanes were. Where did the center of the tropical storm and hurricane move at the time that that storm was producing significant tornado, a significant tornado event across the state of Florida? And a significant tornado event in this case for this study was defined as an event that produced 5 or more tornadoes, or at least one F3 tornado, one strong tornado. And from the example here, you can see all but one of the cases in this study, and this is going all the way back to the 1800s, so it's over 100 years of data, that all the cases except for one were storms over the Gulf of Mexico moving to the north and northeast. So this really shouldn't be a surprise. It's putting some part of Florida in that favored northeastern quadrant when the storms are over the Gulf and moving to the north and northeast. So we may not receive a direct impact in some of these cases from the hurricane. It may be far enough offshore to reduce a direct impact across parts of the state, but we are having impacts from tornadoes, and that may be the main impact that we're getting from that particular storm for some parts of the state. This is a list of the 10 deadliest Florida tornado outbreaks going all the way back to the mid to late 1800s. And most people, when they think of tornadoes occurring in Florida, at least tornadoes that are producing loss of life, you typically think of it as being a wintertime tornado event from a squall line or from an area of non-tropical low pressure moving over the northeastern Gulf of Mexico up towards the Florida Panhandle or towards Georgia. But it's interesting when you look at the data here, 4 out of the 10 cases of the deadliest tornado outbreaks in the state history are tied to tropical weather systems, with Hurricane Agnes leading the list there. But then you can see the 3 other systems as well. So tornadoes can be very, very significant in terms of a tropical cyclone risk for parts of the state. This is another case that we looked at. This is Hurricane Agnes that occurred back in 1972. And from this particular case, it was a Category 1 hurricane. That was its peak intensity. It moved due north over the central or east central Gulf of Mexico, well west of the Florida Western Peninsula, and then moved up into the Florida Panhandle. The hurricane intensity, again, Category 1, so not all that strong when it comes to hurricanes, but it had a very large and expansive wind field. And that wind field encompassed much of the state of Florida, especially in the mid to upper levels of the atmosphere, with very intense winds as the center lifted north over the Gulf. And what happened during this event is when we go back and look at the data archives, we find that at the time it was listed as an event that produced 15 tornadoes across the state and numerous windstorms. And the windstorm terminology is interesting because it was never used in any documentation before or after that time period. It just wasn't used. So we're really not sure why they used the windstorm terminology, but we did a reassessment, a reanalysis of this data. And we found that 28 tornadoes likely occurred during this event, not 15. So many of those events that were deemed windstorms were actually tornadoes. So during this event, 2 F3 tornadoes, 9 F2 tornadoes, 11 F1 tornadoes occurred in 38 hours. A lot of impact to the state of Florida. And you can see from the large red triangles here, these are the stronger tornadoes, the F2s and F3s that occurred across the state. When this event occurred, the Florida population was about 7.5 million people. So we've got about 3 times more population across the state today. So we think an event like this, a setup like this, that will happen again at some time in the future, is probably close to the worst case scenario for Florida when it comes to tornadoes embedded within hurricane rain bands. We do have much improved forecasting for tornadoes these days compared to decades ago, so much better situational awareness before the tornado threat develops, better accuracy of tornado warnings with better lead time, and of course, better situational awareness because the communication system is more robust today, allowing those warnings to get out with plenty of notice to people in the path of those tornadoes. So I think a similar event like this somewhat would be compensated by the improvements of the tornado warning process and also the improvement of the ability to get those alerts out to the public. But at the same time, because of the increased population, it likely would be a very, very serious event in terms of property damage and likely casualties as well when someday we have another event like this repeat across our area. So this brings us to a poll question. Which statement about tornadoes embedded within hurricane rain bands is true? And you've got 4 choices here.
Okay, we've launched the poll, so everyone should be able to vote. We're at about 13% have voted so far. We have about 80% decided on one choice so far, and now we're up to about 45%. We'll leave it open for a couple more seconds. We have folks that have selected each option, but definitely have a majority with this one.
And the majority was?
Majority is 77% for tornadoes often occur in families.
Okay, very good.
We had 18% that said tornado warning lead times tend to be large.
Okay, yeah, very good. The majority definitely did get the right answer there. The tornadoes often occur in families. It's typical for about 5 tornado events to occur with many of the systems that either make landfall or move in close proximity to Florida and put us in that favored northeastern quadrant. So we oftentimes will see numerous tornadoes in close proximity in a relatively short period of time. Tornadoes, many of them are weak, but we oftentimes do see EF1s, 2s, and EF3s sometimes as well, as we just saw from the Hurricane Agnes example. And there's many, many more examples of that occur as well. Tornadoes can occur anytime, daytime or nighttime. They're a little bit more favored during the daytime when it's warmer, but they can occur anytime, day or night. And tornado warnings, even though they're getting better in terms of the accuracy, we're getting more alerts out with lead time. The lead time for TC, tropical cyclone tornadoes, tends to be about 5 minutes on average, so not very long. Whereas tornado warnings during the outside the tornado season of Florida for a wintertime squall line could be more like 10 or 15 minutes lead time. So we're doing better with tornado warnings, but still with a relatively low lead time compared to non-tropical cyclone tornadoes. So one more thing I wanted to mention here is tropical cyclone tornado risk. So the risk is made up of the likelihood of occurrence multiplied by the consequence multiplied by the vulnerability. So if we look in particular about tropical cyclone tornadoes, the risk is that we're going to have numerous circulations develop, many of them that may produce actual tornadoes. Some of those tornadoes could be to the level of EF2 or EF3 in terms of the potential. And then we have to look at the population density across the area of interest, and also the wealth and the mobile homes, percentage of mobile homes across the region, and the overall exposure to those elements. And when we take that into account, this is one particular study that was done recently. There's a lot of different studies out there in the literature that have been done, but this is one of the more recent ones. And this was a county by county vulnerability analysis that was done for tornadoes across the entire nation. And you can see within Florida, a fairly high vulnerability index across the entire state. And what's very interesting is you can see the difference county to county, some pretty stark differences from adjacent counties across the region. And you can even distill this down to a more finite area. You can look at individual neighborhoods compared to another neighborhood For example, when we talked about the tropical storm Gordon example, if the tornado moves across Barefoot Bay, obviously a very high vulnerability there, but maybe only a few miles away, the homes there are not manufactured homes, they're permanently constructed homes and much more sparsely populated across that area. So the vulnerability for tornadoes there would be much less. So it varies greatly. It depends, what is your jurisdiction? What are things like in your jurisdiction in terms of mobile home population, exposure, wealth, density population, and population density, and so on. So it really does change across the area. One more case you want to look at here, and this is probably more in most people's minds since it was more recent, but Hurricane Irma occurred back in 2017. During this particular event, there were dozens and dozens of circulations that developed as visible by weather radar. So as the core of the hurricane was moving up here across west central Florida and moving northward, along the East Coast, the Florida weather offices were dealing with this very expansive, dominant outer rain band. And you can see it extends all the way from offshore Southeast Florida and actually down to the Keys, extending up into Central Florida at this time. And over the course of about 48 hours, this dominant rain band moved across the coastline from the Keys to South Florida, all the way up to southern Georgia. So if we look at the highest tornado production that occurred by hurricane, in terms of going all the way back to the beginning of our weather records, we see that Agnes leads the event, which we talked about here previously. But Irma is number 4 on that list with 23 confirmed tornadoes. I'm going to move ahead to the next slide here. And this shows a 6-hour composite of radar data in which we're looking at sustained circulations from individual showers and thunderstorms. And you can see the tracks of those circulations. So as the colors get brighter here, it goes from yellow to red and especially up into the pink and blue colors, that's indicating a higher amount of rotation occurring within those individual shower and thunderstorm cells as they're moving from the Atlantic to the mainland of the Florida Peninsula. So they began down across the Keys in South Florida. We're looking at a picture here from the Miami radar, again, over 6 hours, composited. And if we look a little bit later in time, here's a similar image from the Melbourne radar, looking at another 6 hours of time. And again, these are associated with that dominant rain band, which I showed you previously. As it lifted northward up the peninsula, within that rain band, individual circulations are developing, multiple water spouts out over the Atlantic are likely occurring. And as those circulations come on shore, some are weakening, some are being sustained, and some are actually strengthening as they move towards the coastline or move just a little bit inland from the coastline. And then finally, from the Jacksonville radar perspective, the rain band, the primary rain band, when it got up to northern Florida and even into the South Georgia area, we're seeing more of these intense spiral circulation bands moving on shore, the coastline of northeastern Florida. So in total, over a 48-hour time period, because of those tremendous amount of circulations that occurred as evident on radar, 91 tornado warnings were issued by the Miami, Melbourne, Tampa, and Jacksonville weather offices over a 2-day period. And just by the Melbourne office, we issued 51 tornado warnings. We know those are a lot of warnings. It's the most by far of any event that's been worked in recent memory. There was information overload. It saturated the communication systems as this was occurring, and we knew that was happening. But at the same time, we have a goal. We have a responsibility of getting lead time warnings out for tornadoes. So we issued those tornado warnings when conditions became favorable, according to radar. On the right-hand side, you can see the polygons of the danger areas that are depicted with each one of those individual 91 tornado warnings overlaid on the map of Florida. So what actually did happen? Well, in the subsequent days after the hurricane moved by, the National Weather Service offices sent their staff out into the field to do damage surveys, and we were able to confirm across the peninsula of Florida 23 individual tornadoes, 6 of them EF0, 14 EF1s, and 3 of the EF2 intensity. What was very interesting, though, is because the hurricane paralleled the Florida west coast, it produced sustained hurricane winds, Category 1 over the western side of the peninsula, and gusts to Category 1 intensity across the eastern side of the peninsula. So the entire peninsula of Florida was impacted by background winds, sustained or gusts to hurricane force, Category 1 hurricane force. So the weaker tornadoes, the EF0 tornadoes were very, very difficult, if not impossible, to determine after the fact when we're going out to make a tornado damage survey, because the background winds of the hurricane masked the ability to make out those swaths of damage. But the swaths of damage associated with the stronger tornadoes, the EF1s and 2s, definitely stood out above and beyond the background damage produced by the hurricane itself. So we believe there were many, many more tornadoes, at least across East Central Florida, than the 23. This was probably the #1 event in Florida's history, but we can't confirm that because we couldn't make out those weaker EF0 tornadoes after the fact, given all the damage that occurred. Also of interest, there were no deaths or injuries associated with any of these tornadoes, even the EF2s that occurred across the area and produced considerable damage. And when we talked to the folks that were back at their homes that had evacuated during the hurricane and were back home a few days later when we were doing these tornado damage surveys, they told us, yes, they left their home for a couple of days because they maybe lived in a manufactured home or a mobile home, or they lived in a home that was built a long time ago and had old building codes. So they left because of the winds of the hurricane. And of course, along the immediate coast, they left because of the threat for storm surge. So the tornadoes occurred, many of them very close to the coastline, and they occurred in those evacuation zones in many instances. And we think that because people evacuated, that limited the casualties that occurred during that event. Just a couple images here of the typical type of damage that we came across from these tornadoes. So again, it was very prominent that this damage stood out above and beyond the background damage of the Category 1 hurricane force squalls that occurred across our area of East Central Florida, and the same thing likely occurred across other parts of the state. So very impacting, especially when we get up to that EF1 and EF2 intensity events. So one more slide here before I turn things over to Rob. I just wanted to mention that he's going to start talking about tornado messaging and communicating the hazards associated with tornadoes. But one dilemma that we face is that during the evacuation time period, say 24 to 48 hours prior to the core of the hurricane reaching a particular area, evacuation orders are in place, and the advice is to leave as soon as possible if you're in a mandatory evacuation zone. But that's the same area many times that are impacted by those lead rain bands associated with the tornado producing cells. So this could be to the north and northeast ahead of the core of the hurricane, which folks are evacuating for, but at 24 to 48 hours in advance, that primary rain band is bringing a tornado threat to that same area. So now we're issuing tornado warnings and we're telling people, take cover now, move to an interior room in the lowest floor of a sturdy building. At the same time, evacuation orders are in effect. So it's kind of a disconnect with two pieces of information being passed to them. And they have to temporarily limit or stall their evacuation or their last minute preparation to be safe from the tornado threat, and then go back to the evacuation or final preparations once the tornado threat is over for their particular area. So we're very aware of this. We're working with our emergency managers to maybe perfect the messaging, to do a better job, to make sure it's not in conflict with the larger scale evacuation orders in place for a particular area. And at the very end of the presentation, we'll touch a little bit more upon this topic. But for now, I'll turn things over to Rob in Miami.
All right, good afternoon, Scott. Thank you, Scott. Good afternoon, everyone. And continuing on, let's focus now on the impact messaging, starting in the planning stage and then moving forward to the actual event. You've seen these graphics the last several days, the hurricane threat and impact graphics, where we basically downscaling hurricane center information down to the local scale, and also doing an assessment of the threat and impacts from each of the four main hazards of the storm. So it provides a nice quick look of the relative threat impact levels at your area. So we feel that certainly these are or could be excellent local planning tools, and these are also updated every 6 hours. So they're updated with the latest National Hurricane Center information. Now, when it comes to specifically the tornado impact graphic, this information really is downscaled not only from the National Hurricane Center track and intensity forecast, but also from guidance from the Storm Prediction Center. And we'll talk a little bit more about the specific SPC guidance here over the next few slides. So you advance over to the next slide, please. And now we'll look at some specific examples of how we use these hurricane threat and impact graphics in our briefings, in our decision support briefings that we provide to our emergency managers, safety officials, and first responders. So here's an example from Scott at the Melbourne office. We see the threat levels. The levels range from yellow all the way to purple. So as the threat, technically they start at none, which is the gray areas. But really, once you start with once you have an actual threat, then you go from yellow to magenta. Yellow being lower threat, and of course going up the threat scale. So this, I believe, is an example from Irma, which Scott showed some stats from. And at that time, you see the highest threat level was across East Central Florida, where there was at least a threat of several tornadoes. But there was still a threat acknowledged for much of the rest of the peninsula. And so you can see, so with this information, with these slides that we produce, you also see here an example from the Miami office. Same format, the color scale, the threat scale is the same. And just providing additional information pertaining to the locations of primary concern and also timing. So we want to make sure that information is included, so people that are using this information have an idea of not only what areas are under greatest threat, but when. That's very important. All right, going to the next slide, please. Now, how do we downscale or use that Storm Prediction Center information? Well, I'm sure a lot of us or most of us are familiar with the severe thunderstorm outlooks that the Storm Prediction Center puts out. That starts beginning 8 days out. So they have basically 8 days where they forecast, where they have an outlook of severe thunderstorms and tornadoes. So similar to the map you see there on the left. Now, when it comes to tropical cyclones, due to the high, still rather high level of uncertainty, even as close in as day 3. And as we know, as Scott showed at the beginning, the favored areas for tornado formation and tropical cyclones is, it's fairly well defined. So, knowing exactly where that right front quadrant is going to be, it's the farther out in time you go, obviously the more uncertain it is. So usually, Storm Prediction Center will wait until day 2 to put parts of the area in some kind of a threat level, whether it's marginal or slight or enhanced or moderate. In many cases, probably will be even like in a slight. In the case of Irma, however, we actually were in moderate. Actually, that's enhanced. So that's level 3 out of 5. So that's pretty high for a tornado risk, especially for Florida. But considering that some of these tropical cyclone events can be quite prolific producers of tornadoes. So sometime shortly after that, or Scott mentioned earlier, about 12 hours or so before, that's when we'll then go with we'll coordinate with SPC, and tornado watches would be put up for the area. And again, you'll normally see those in the favored right front area, like in the example here. This again is from Irma, where you had the tornado watch in effect for central and northeast Florida, and also extending up into Georgia. And watches they're typically issued for most hurricanes. In fact, I would even say certainly even most tropical storms, especially the ones that have the criteria or the conditions that Scott highlighted at the beginning of the presentation. Right, next slide, please. Now, then from there, we start to actually, as the bands start to approach or start to get close to the coast, then it becomes time to put up warnings. And Scott mentioned already, one of the biggest challenges, if not the biggest challenge, is putting these out with enough lead time, with enough advance notice. they move very fast. The cells associated with tropical cyclone bands can move 60 miles an hour or more. So you may be seeing something that's 20 miles offshore. You think you have, 10, 15, 20 minutes, and really you only have a few minutes because they're moving so fast. So, and also these cells, the rotational signatures can develop very quickly, and they're not as deep or extend as far up into the atmosphere as the more traditional supercell, non-tropical type tornadoes. So they definitely present a big challenge. And also the other challenge with that is not the tendency, but the issue of issuing so many tornado warnings that the overwarning can be an issue. All right, well, speaking of warnings, this is a poll question, and this is dealing or addressing WEA, wireless emergency alerts. So the question here is which National Weather Service warning below, which of the four, is not activated on wireless emergency alerts or on WEA-capable smartphones? So please select one of those.
The poll is launched and we're kind of split so far. We have about 35% of the votes in. We will give everyone a little bit longer. We're up to 55% voting now. Okay, we'll go ahead and close the poll and show everyone the results. So we had 61% that said extreme wind warning, 23% said severe thunderstorm warning, and 13% said flash flood warning.
Yeah, this is a tricky one. The correct answer is severe thunderstorm warning, actually, the choice A. And then, this is fairly new, and actually the extreme wind warning wasn't added until fairly recently. Tornado and flash flood were one of the first ones that when WEA started, I guess back like in 2013, I believe it was. Those were the first ones that were incorporated. Then eventually we added extreme wind warning into that. So now speaking about WEA or these wireless emergency alerts, when it comes to tornadoes, well, the way it works is, for those of you who, maybe this might be a fairly new concept for some of you, warnings are issued, and then, when we issue a warning, let's say, for example, tornado warning, let's say for County 1 there, every cell tower in that, that's in that warning box or warning area will get highlighted, or I'm sorry, will get pinged with that warning message, and then everyone, who's within range of those cell towers, their devices will receive a message saying that they have a tornado warning. Now, what frequently happens is those cell towers that are on the borders, let's say of another county, of course, cell towers, the coverage area of the cell towers don't conform to county lines. So the coverage from those towers can easily, that are on the borders, can easily extend into other counties that may, or areas that are not within that tornado warning. So yeah, there is some overwarning, if you will, when it comes to the areas that the people that receive these messages that are actually not in the tornado warning area, but still are probably pretty close by, pretty close to that warning. So the geo-targeting is improving, and the technology is gradually improving, and hopefully, the goal, at least over the next coming years, is to try to reduce as much as possible the overlap, or the areas that are being alerted, or they're receiving these messages that are actually not in that warning area itself. So I think we're turning it back over to you, Scott, for the last few slides.
Okay, very good. Thanks, Rob. And I just want to finish up by looking at some potential improvements to the tropical cyclone warning program as we go forward over the next several years. So to begin with, I just want to mention the way we currently do things. This is a depiction of what a rain band would look like on a weather radar. And within that rain band itself is individual shower or thunderstorm cells. And let's just say those cells are starting to become strong, starting to show some signs of organization, some signs of rotation. and they're lifting up to the north and northwest, bending around that outer rain band. Well, today, the way we would do it is most of the time we're going to issue warnings for the individual cells. The warnings we issue for tornadoes are supposed to be storm-based or impact-based warnings, and they're supposed to be done individually for each one of these cells. So if all 5 of those were showing a high potential for becoming tornadic, we would probably issue 5 separate tornado warnings for that area. But if the area is a relatively small area, the cells are in close proximity, and they're likely to spin up over a relatively short period of time, what we've done in the past is we could issue 1 tornado warning to encompass maybe 2 or 3 of those different cells. So rather than having 3 different tornadoes warnings go out through the communication network and over populating what is out there message-wise, we could do 1 tornado warning. And then maybe later on in time, a couple other cells start to show greater chances for becoming tornadic, and we issue a tornado warning for those 3 cells. So what it would look like in terms of the text bulletin that comes out is we would just state, rather than the cell is likely to produce a damaging tornado in this area, we would just talk about several tornado producing cells were located near a particular area, what their movement is, what the impact is likely to be, and then what the locations are that will be likely impacted by that collection of cells over the time period of that warning. And rather than being a warning that's in effect for maybe 15 or 30 minutes duration, it might be for 30 or 45 minutes duration, like this example we're showing here in this particular slide. Going forward a little bit more in time, because that ability exists today. It's not used a lot, but it can be used by the individual forecast offices as long as it's not overused. But something that we're looking at going forward is there is talk internally within some portions of the National Weather Service if we could be given the ability to issue a larger scale, a larger geographical area that could be placed under a tornado warning for a part of that larger rain band that's moving on shore. So in a case like this, we may not be tracking individual cells that are showing rotation yet, but we know as that entire rain band continues to move on shore within the area here depicted by red, many locations there within that area are likely to be impacted by tornado producing cells here over the next, say, 60 minutes. So it would be a larger scale warning affecting maybe 2 or 3 Central Florida sized counties at one time. It would be in effect for maybe 60 minutes of time rather than 15 or 30 or 45 minutes of time. So it's an option that we don't have currently. We need approval to change the way we do things, to do things this way, because we're supposed to be doing very specific storm-based warnings for tornadoes right now. But these are discussions that we're having to try to compensate for having too many warnings fly out onto the communication network at the same time and really oversaturate the communication network, so the messaging becomes more confusing and complex. We want to minimize that, obviously. And one more slide here is this one is a little bit more controversial, but there's some talk beginning on this as well, is if we can prove that the science and the technology allows us to distinguish between cells that may more likely produce weaker tornadoes, say EF0s, from the cells that are more likely to produce EF1 and stronger tornadoes, would we be allowed to issue tornado warnings for only the higher level tornado threat? So if an area of Central Florida is going to be impacted over the next 6 or 12 hours by hurricane force, say Category 1 force winds, like the background winds we talked about during Irma, everyone's going to receive those winds. Is it really worth issuing individual tornado warnings for cells that are going to produce tornadoes with the same type of wind, EF0 tornadoes, equivalent to Category 1 hurricane winds? Or should we reserve the warnings for higher end tornadoes, those that have the potential to produce EF1 or stronger damage that would be enhanced above and beyond the background winds of that Category 1 hurricane? So, 2 issues there. One, do we have the ability to do that with a high degree of accuracy? And then if we do have the ability, would it be worthy? Would it be worth doing that? So after the Hurricane Irma event, our staff, National Weather Service Melbourne, went out and we brought together a couple informal focus groups with different emergency management agencies. And we showed them this information. We replayed back the data with all the warnings that were issued during Irma, and we asked them that question. If the technology could do a decent amount of, a decent job allowing us to discriminate between weaker tornadoes and stronger tornadoes, would it be worthy of not issuing tornado warnings for EF0s if the background Category 1 winds were going to affect that same area, and restrict the warnings to EF2 tornadoes and stronger? And the input we got from just about everyone we spoke to is, yeah, that sounds like a good way of doing things, to minimize the amount of information being pushed out at one time, and just stick to the cells that have a greater capacity to produce more significant damage that would be embedded above and beyond the background state winds of the hurricane itself. So this is a very early internal discussion. If it ever get agreed to and the technology and the science allows it, it would probably be many years away before it would be implemented. But just want to let you know these ideas are being talked about to try to mitigate some of the impacts that we're seeing from issuing too many tornado warnings when they're evident on a radar. But again, as I showed you with the Irma slides, the potential is definitely there. So, you know, we had to do our job and had to issue those warnings as our responsibilities dictate. So with that, I'm going to turn it back over to Dan.
Thank you, Scott. And I'm going to switch it over to Michael Spagnolo. He's the Deputy State Meteorologist with the Florida Division of Emergency Management. Go ahead, Michael.
Yes, hey, good afternoon. Happy Friday, good to talk to everybody again. It's always interesting to me how some of these hurricanes can be such prolific tornado producers, such as Hurricane Irma, and then other ones like Hurricane Michael produce so few. So, you know, it really, when these storms are producing tornadoes, it doesn't have to do with the strength of the hurricane. It's more so to do with just the background environment that's driving the hurricane, steering the hurricane, and allowing its intensity to either decrease or increase. That's probably more related to that. So when you are looking at your forecast, just because the hurricane is a Cat 1 or a Cat 5 or even just a tropical storm really doesn't have much correlation into that actual number of tornadoes that they'll pose. And Scott was talking about, just to reinforce a few points he mentioned, you know, looking at some of those systems and either early in the season or late in the season that tend to be hybrids, either non-tropical or subtropical. Something that comes to mind is Tropical Storm Nestor from, I believe, over in 2019. Those types of events, you can really get the tornadoes to form outside of that right front quadrant, especially when you have fronts involved. So tornadoes are certainly probably one of those leading threats that they can occur outside of that forecast cone. And just because your region is not in that forecast cone, not in the surge, not in the wind, not even in the flooding rainfall, tornadoes can certainly still be a threat to your area. You know, hurricanes, because of the power outage and the damaged infrastructure that comes along with just a hurricane in general, it's another good place to plug in that having multiple ways to receive those warnings. We've all seen INWS and NWS chat go down. We've seen NOAA radio transmitters go down. We've seen our cell service, internet, and the power go out. So, of course, we don't want all those things to happen at once, but you need to make sure you have multiple ways to receive those tornado warnings at your EOC, for the residents, at their homes. Having multiple ways will make a difference, especially in a time when the infrastructure is going to be tested with an incoming tornado, a hurricane. Another thought is just, you know, if you've got contingency planning, so just to have that in your back pocket. If your EOC is hit by a tornado, if your shelter is hit by a tornado, you know, 90 miles an hour during a hurricane in one direction, all, you know, can react and cause different damage to a building. So even if the building may be rated to withstand 120 miles per hour during a hurricane, the sudden pressure changes, the sudden change in wind direction that comes with a tornado, it's much more violent and sudden. The damage to the building may be different. Say if it's only 100 miles an hour, it may still be able to cause damage to your building that may compromise it. So it's always something to think about, that, you know, even if you're getting these weaker tornadoes, they still can cause enough damage to make the building unsafe, especially if it's a piece of critical infrastructure in your county or in your region. And then lastly, I wanted to say thank you to the several hundred people who have joined these trainings over the last week. We really appreciate you taking the time, and we hope you've learned something heading into hurricane season 2021, which unfortunately looks like it's probably going to be more active than not. If you've, you know, over the week, we've talked about HRVAC a couple times, and I just wanted to put one quick plug into additional trainings. So for those of you that are looking, we have gotten a lot of emails asking about HRVAC after the couple mentions from the storm surge one and then the winds earlier in the week. HRVAC.com, They are putting on trainings in the second week of June, June 7th to 11th. So if you enjoyed these once a day for an hour, hour and a half, quick training sessions just to cover a few topics, they're going to hold them in a similar fashion. So there'll be one each day, starting with the introduction to the basics of HRVAC, and then transitioning later in the week into more technical uses of the storm surge projects, the evacuation timing, and then eventually with the brand new exercise creation tool they have in HRVAC. So you can check that out, HRVAC.com. There's the links to sign up to register for those webinars. And you can always reach out to us if you have any questions. With that, I'll turn it back over to Dan.
Thank you, Michael. And let me just show my screen here. There we go. So we just have a few questions. And